In this video, we're going to cover question number 4 from 2014. You should have already done this. This is just to be able to grade it. So with that said, let's go ahead and get started. In number 4, we're given a table of values where V sub A of t, is given, specific values are given, and t is measured in minutes and velocity is measured in meters per minute. And it says the train runs back and forth along the east-west section of railroad track. The train A's velocity measures in meters per minute is given by the differentiable function V of A of t, where time t is measured in minutes. Select values of V of A of t are given in the table above. Part A, it says find the average acceleration of train A over the interval 2 to 8. So we're looking for the average acceleration. We can't find the exact acceleration, but we can find the average acceleration. Given velocity, we just need to find the slope of velocity over that interval. So this would be V sub A of 8 minus V sub A of 2 over 8 minus 2. And so that would be negative 120 minus 100 all over 6, which is negative 220 over 6. And then we can reduce that to be negative 110 over 3. And it doesn't say indicate units of measure, but just for good practice, the units would be meters per minute squared. So that's part A. As far as grading part A, you would get 1 point for the average acceleration. So this is our answer here, and you get 1 point basically for your answer. Now you're not going to get your point unless you show your work, so make sure you do that. Part B, it says, do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time within 5 is less than t less than 8? So notice this is a type of question where it says, does it support, or is there a time when that should entice you to think about all your theorems. You have the mean value theorem, the intermediate value theorem, and the extreme value theorem. In this case, because we're given velocity and we're asking about velocity, that's going to imply the intermediate value theorem. So you remember the intermediate value theorem says, if I have a point that's, let's say this is time 2 and this is time 6, and this height is 80 and this height is 20, if this function is a continuous function over that interval, this function must pass through every y value between 20 and 80. So looking at the data that we have in regards to the interval 5 to 8, if we just look at the coordinates there, coordinate 5 gives you a velocity of 40, and then coordinate 8 gives you a velocity of negative 120, so we're down here. And the question is, does the data support the velocity being negative 100 for some value between there? Okay, so plotting those data points, we can see since this function is a continuous function, and it says, and we'll get to the justification in a second, it says that velocity is differentiable, therefore it's also going to be continuous. Since that's continuous, and it starts at 40 and it goes to 120, it's got to pass through negative 100 somewhere in there. So that's kind of the picture of that. Let's go ahead and justify this now. We're going to say something along this line. For part B, something like, since V sub A of t is differentiable for 5 is less than t is less than 8, it will be continuous for 5 is less than or equal to t less than or equal to 8. Therefore, the intermediate value theorem applies. Okay, so that's where we're going with this. And so we could say something like this. Since v sub, let's see, v sub a of 8, which equals negative 120, is less than 100, or sorry, less than negative 100, which is less than, let's see here, we're looking at 5. So for 5, less than 40, which is equal to v sub a of 5. So we have a statement here that we're basically saying, since negative 100 is between negative 120 and 40, and these were the values of the velocities at those 2 points, since it's between there, then we know there will be a time where the velocity is negative 100. So we can say this, there is a time t where train A has a velocity of negative 100. Okay, so that was a bit of a trick there. As far as points go, you're going to get 1 point. You're going to get 1 point for making some sort of comparison between this inequality. So noting that we have a negative 120 on one side, a 40 on the other, and that negative 100 is between there. You get 1 point for that. And then you're going to get 1 point for using the intermediate value theorem to justify why there is a point. So in order to use the intermediate value theorem, you have to state that the function is continuous. If you didn't state it's continuous, then you're not going to get that point. But anyways, that's 2 points for part B. All right, going on to part C. Part C says, at time t equals 2, train A's position is 300 meters. So we can see that in part C, we're given an initial condition of 2, 300. So at time 2, the position is 300 meters east of the origin station, and the train is moving to the east. Write an expression involving an integral that gives the position of train A in meters from the origin station at time 12. So we're looking for the position. We're looking for position when t equals 12. So you remember position is the initial condition. So the position at 12 is equal to the initial condition plus the integral from the time of the initial condition to the time that I'm looking at of the velocity function. So that is our equation for position, and we can just type that into our calculator and get an answer there. Actually, we can't, because this is not a calculator problem. And then it says, let's see, write an expression involving an integral that gives the position of train A. So we did that. And then in meters from the origin, blah, 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 it says use a trapezoidal sum with 3 subintervals indicated by the table to approximate the position. So we're looking for the integral from 2 to 12, and we're looking at 3 subintervals. So we're going to say that our first, remember the equation for a trapezoid, area of a trapezoid is 1/2. B1, base 1 from 2 to 12 is going to be 100. Base 2 is going to be 40. And then the height, or the width of that trapezoid, is 3, plus 1/2 of base 1 of the second trapezoid is 40, base 2 is negative 120, and the width is going to be 3 again. And then the last one, plus 1/2 of negative 120, plus negative 150, and then the width there is going to be 4. So that is the Riemann sum that gives you your integral expression. And then we have to add to that 300. So we'd say x of 12 is approximately this. And then from here we can simplify this. I would actually recommend not simplifying this. All of this put together gives you a position of approximately negative 150. So that is our answer. But when it comes to point values, and we've talked about this in the past, simplification is not necessary. So as far as points go, you get 1 point for the position expression. So you're going to get 1 point for that equation or that expression for position. You're going to get 1 point for using the trapezoidal sum correctly, so 1 point for this part right here, and then you're going to get 1 point for your answer. Now, this answer, having this doesn't really matter. As long as you had x of 12 as this, without simplified, you'd automatically get that point. So if you have this equation and then this expression for position, you've got all 3 points. But if you make an error somewhere in here, you know, from your work from here to here, and you get some different answer than negative 150, even though this is all correct, you're only going to get 2 out of 3 points. But if you just ignore this, you get 3 out of 3. So it's better not to simplify if at all possible. All right, so that's for part C. Looking at part D now. Part D, it says a second train, train B, is moving north from origin station. So we have one train that's going back and forth, east and west, and we have another train that's moving north from the station. So this is train B, and this is train A. It says at the time the velocity of the train B is given by this expression. So we got velocity of train B is given by negative 5t squared plus 60t plus 25. And at time t equals 0, when t equals 2, the train is 400 meters north. So that's the initial condition of its position. So this is x of b of t. Okay, so that's the position of the train B. Find the rate in meters per minute at which the distance between train A and train B is changing. So we are looking for the rate of change of this length. So we'll call that c. So we can create an equation here where we have a squared plus b squared equals c squared. And these are the distances between them. Now we can take the derivative in respect to time to figure out the rate of change at which this is changing. So we take the derivative of this, again, respect to time. So that's 2a times a prime plus 2b times b prime equals 2c times c prime. And then from here we can just plug in some values that we know. Well, we know a prime is the velocity of train A when t equals 2. So the velocity of train A when t equals 2 is 100, given by the table values. We don't know the position of A necessarily here. Let's see here. Oh, we actually do. From part C, it says that the train's position is 300 meters east of the origin when t equals 2. So when t equals 2, the position of train A is 300. All right. And then plus 2b, the position of B at 2 is 400. So 2 times 400. And then B prime is the velocity of train B at t equals 2. So we have to figure that out. So we just plug 2 into that. So B of 2 is negative 5 times 2 squared plus 60 times 2 plus 25. And then that ultimately simplifies to 125. So we have that. And then that's equal to 2 times, well, I don't know how far apart they are, but I do know how far they are from the origin. So since the triangle has a length of 300 here and 400 here, then doing the Pythagorean theorem all over again would give us a distance of 500 between the two. So the position here is 500, or the distance between the two trains is 500. And we are looking for the rate at which they're moving apart. So we're looking for C prime. And then solving all of that, I'm not going to dwell on that. C prime is 160. And so our final answer is 160 meters per minute. So they are moving away from each other at that rate at t equals 2. As far as points go for this problem, you're going to get 2 points for taking the derivative correctly. So using implicit differentiation and the chain rule here. So you're going to get 2 points for that line, and then you're going to get 1 point for the final answer. All right, that covers question number 4 from test 2014. Go ahead and grade yourself. It was out of 9 points altogether. Be honest with your grading. So now we have done 2014 number 4. Your next job is a quiz. So I want you to do this with all honesty on your own. Set a timer for 12 minutes. You're going to do question number 2 from 2016. This is a calculator-based problem. Again, set a timer for 12 minutes and then watch the next video to score yourself.